All right, time is 7 o'clock, so let us start on time. Very good evening, one and all present for this 2 days workshop on R programming. We have with us Dr. S. Murugappan sir, who is presently working as a professor and director, School of Management Studies, Bannari Amman Institute of Technology, Sathyamangalam. It's a great pleasure to have sir for both the sessions. He is a seasoned academician having experience over 30 years, including corporate and academia. And he is an authority in the area of statistics and financial modeling. He has contributed and published many papers in reputed journals, and he is a resource person for many top corporates for their MDP program. Thank you so much, sir, for joining us as a
Thank you,
resource
sir.
person,
Thank you
and
so
we are
much, sir.
looking forward to learn from you. Thank you so much. Kindly take over.
Thank you, sir. Thank you so much, sir. I'm sharing my window.
Right, sir.
From the participant side, I would like to ensure my window is visible and also my audio quality, it's okay.
Yes, sir.
Right, okay. Uh, my dear participants, my dear colleagues, it's a great pleasure to sharing my experience and knowledge, what I have gained in the R programming. I hope all of you are the beginners and you are starting with the R programming as a first baby step you are taking up. With this pre-assumption, I am taking you to from the very scratch. Let us start with the intro about the R programming, and thereafter I will take you to the nitty-gritty of the R programming. 3 hours is too minimal. Even then, what we can learn from this 3 hours is the foundation further make you to take off in the area of R programming. In the basics, I'm trying to cover about the intro. It's a language of statistical computing that it has been developed by Rose Ika and Robert Gentleman. Both of them are from New Zealand. In the 90s, they developed it. It's an open source. The base is an open source implementation of S that it has been developed by John Chambers in the Bell Laboratory actually in the years 1980s. Once if you are learning the R is similar to Python. Easily you can grab the knowledge in the Python also. And it is a statistical, especially to leverage the statistical techniques, you can apply R programming. And moreover, the highlight of the R programming is its visualization capabilities. Highly extensible, meaning you can get the R programming into Excel or pivot, or there is a Excel in the sense of pivot in the sense of the business analytics and Power BI, Tableau, any kind of a analytical tool in which you can bring the R programming. That is a beauty. And I would like to restate once again the capability of R programming really will help us to leverage the Excel program. Excel is everywhere and we are extensively using it. That one we can leverage. With this basic introduction about the R, I'm taking you to the advantages of the R. As usual, whenever I'm talking about the advantages, disadvantages is also there. That also I'm trying to cover. It's an open source, it's a free. You can download it from the R programming website. Either that is for Mac or it's a Windows, whatever may be, you can download and you can install. And the latest updates you can download and you can keep on update. And it is a master at graphics. The depth graphical statistical graphs we can construct. That is a command inline interface, meaning here we can write the then again the functions, or we can execute the functions line by line. Instead of a set of lines to be executed together, if we are running line by line, it's a very easy to identify the bugs. And moreover, it is a reproducibility, meaning here in the R scripts, whatever we are applying the functions or we are writing the code, that it can be reused. It's a very simple, easy to understand, and uh, we are using the R Studio also to make it more interactive one. It's a vibrant community is there, and this communities keep on contributing it. And our packages, n number of packages are there. All the packages, then again, we can use it. Financial packages are there. Each and every area, then again, the extended packages are available, developed by the vibrant community that can be used extensively. Then, what are the disadvantages? The disadvantages are easy to learn, but hard to be master in that particular area. So command inline interface daunting at first, but again, the problem is there. It's not like a Power BI or Tableau or that may be an Excel. Again, we should have a little bit more caliber on writing the codes. Poorly written codes hard to read and maintain, and poorly written code is very slow. But even though a number of disadvantages are there, then again, huge number of advantages are there, and then again, we can leverage the R programming. In this session, I'm trying to make you to understand the nitty-gritty of the R programming. That insight, if you are getting it, further reading of the books or viewing the video or whatever may be the source in which you are trying to gain the knowledge, it's very easy for you. In such a way, I designed it. Now I'm starting with an R window. This is an R window. I'm talking about R Studio. R window is the one, it's a real package. And in that, then again, I can write the codes and I can execute it and I can get the output. But it's not that interactive. As an extension of R, I'm using R Studio, that it will be an interactive one. It's very easy to handle the script files and run the programs and get the outputs. In the R window, I'm showcasing the actual window of the R, and the text boxes that it has been shown in red color and the yellow colors are all highlights. As usual, the top one is a title bar, followed by menu bar, file, edit, view, miscellaneous packages, window, help, followed by standard toolbar, and the window, what we are viewing it with the lines, that is called as a console, to write the codes and get outputs. Okay, right. But we are not using R window. Straight away, I'm taking you to the R Studio. And that R Studio also I'm trying to introduce to you the environment. This is the R Studio environment. In the R Studio, when you are seeing it, there are 4 quadrangles. One is the source, that is the number 1. I have mentioned it in the text box. In that, we are writing the scripts, or I can simply say that it's a script files. I can write the code and I can preserve and I can recall. The second one in the right hand side is a console. In that, then again, I have to run the programs and I'm getting it in the output files. Okay. Not output file, sorry, the outputs actually. It's not an output file, outputs. The third one is an environment and a history. Environment is nothing but here it is a workspace. We are calling it as a workspace. Whatever the variable, I have to bring it to the workspace and I have to write the scripts and I have to run it in the console and I have to get the outputs. Okay, are you clear? Once again, I'm repeating. The source is a script file. In that, I have to write the codes that it can be preserved, like a Word document or Excel document or any other document, that it can be saved, that it can be recalled. Whenever I'm running the script file, I'm getting the output in the console. Okay. And whatever the variables I'm using it for the analysis, or the tables or variables, whatever may be, that is in the workspace, my workspace, that is in the environment. That is a third is an environment. The fourth is a one that it talks about the files, plots, packages, and help. If I'm taking the output of the graphical outputs, I can get it in the plots only, not in console. And the files, I can access the files. The packages, whatever the packages that it has been installed in my R programming, that I can view it in the fourth quadrangle. Help is also there, right? So in this, anybody is having a doubt, you can ask now. I'm passing for a 30 seconds. I am in the presentation view, so I am not able to see the Google Meet. Now I'm requesting any one of you can come forward to say whether are you clear about R Studio window. There are four: source, console, environment, file. The source is a script file. I can write the code, I can save, and I can recall. Okay, it's like a Word document or Excel document or PowerPoint, like any other document. Whatever I am running it in the source, the outputs I can get it in the console. The graphical outputs I can get it in the fourth item, plots. And the environment is a one in which whatever the variables I am handling it in the R, that it will appear here. Without the items variables in the environment, I can't run the programs. Okay, right. And the file is the one in which I can see the files. It's a kind of a directory, how in the Windows we are seeing it. In addition to that, what are the packages that it has been installed in the R programming, and the help is also there in the fourth item. Now I am passing for your reply. Even if it is a very clear, please say it's very clear or yes. Yes? Clear? I'm coming back to window. It's okay, fine. Are you clear? My
Yes, sir.
voice is,
It's clear,
yeah.
sir.
I think you are sending a message. I'm seeing the message. It's very clear. Right. Okay. Now I'm moving to the next level. When we are talking about the, just before that, I would like to open up the R Studio, and I will also open up the R also. Please see here, I have installed it. Can you see the R? Can you see the R? Can you see the R program? This is a window. This is a console. Okay. I'm minimizing it. Now I'm opening a R Studio. R Studio also we have to install. First, we have to install the R, and subsequently we have to install the R Studio. Both are free versions that is available, and I have installed the latest version. This is an R Studio. It's loading. Already what I have loaded with this, that it has been opened up. I'm opening up the script files so that you can see. 1 minute. Right, okay. And can you see the windows? And what I will do is I will zoom. Okay. I will zoom so that can you see the untitled? This is the one script file I opened. See here, I'm closing this window. Script window has been closed. Now in the file menu, new file, script file. If I'm opening up, that file will open. See here, untitled one. Like how we are getting it as a sheet one, sheet two, book one, book two, word. Then again, word one, word two. Like then again, how we are getting it, the similar way that it gets. When I'm saving it, that it will ask to name the file, I have to name it up. And right hand side, if you are seeing, see my mouse pointer, it's an environment, history, connections, tutorial. The environment is nothing but it's a workspace. Whatever the variable, whatever the library I am using it, and all this that it will appear here. Without bringing the variables and packages into the environment, I can't use it. Every time I have to bring it. Okay, right. If it's nothing, environment is empty. Please see here, the word environment is empty. So the untitled one, this is a script file, and the next one is an environment window that it contains of 4 tabs: environment, history, connections, tutorial. Whatever I have done it, that in the history I can see it. Okay, and in the bottom left hand side, if you are seeing console, terminal, background job, there are 3 tabs are there. The console is a window in which I can get the outputs. See here, the prompt is appearing, blinking. Can you see the prompt in the top bottom? Right. In the right hand side, below the environment, this is a plot one. In that, I can see the plots file. Please see here, these are all the files. That is a file from my laptop. Okay. I can see here, see in the home, see here in the home, in the file, the home, the end, there are some 3 dots, go to directory. Tool tips are available. What you can do is you can put a cursor and you can see the tool tips and you can get the help. If I'm clicking the directory, so here, see here, I can choose the directory in which the files to be shown. Here I'm taking the D directory. In that I'm taking all exercises and I'm opening up. See here, all exercises. I'm keeping it here that it appears here. This is a file. Plot in which the graphs will appear here if I'm running the code. Packages, see here, these are all the packages. These are all the packages, user library. In that library, what I'm using it, and by default R contains packages. That is also there. Even if you are scrolling, see here, system library. System library is there. From the library, we have to load the library into the environment. Even though n number of libraries are there, all the libraries will not be loaded into the environment. I have to bring it into the environment first. Thereafter, I have to run it through the script files. The outputs, I can get it in the console, and the plots, I can get it in the plot area. Okay. The help obviously is a help one. You can get the help from that. The viewer, this is for on, that is a web view. And the presentation, again, it's a presentations. This is beyond our scope of our coverage. What you are supposed to learn here is a file, plot, packages. That is more than sufficient. Here is a console windows. Okay. And this is a script file, and this is an environment and history. We are obviously using these windows. Okay. Shall I move further? Shall I
Yes,
move
sir.
further? Right. Okay.
Yes.
Now, my dear friends, it's simply I can write the. It's like a calculator. I can use it. Just I will showcase to you. Then again, here. So, for example, here I'm taking you the display, and thereafter we can do. See here, this is a console. Can you see the console? Like a calculator, I can work. Simply in the prompt, after the prompt, this is an arrow mark, this is a greater than arrow mark. After which, if you are typing 1 plus 2, you can get the output 3. Suppose if you are typing the text, this is an R workshop with the double quotes, you can get it. If you are getting the single letter, then again number, then again you will get it. Just we can run it here. Okay, I will showcase to you. See here, what is the one we have seen first? That is in the console window. See here, I'm increasing the console window. Please see here. Okay, in the bottom, I'm writing 1 plus 2. For run it, what I have to do is not simple enter, it's a control plus enter. See here, control plus enter. I'm getting it here. Can you see the window? Can you see here? I have increased the size also. Now it's okay, fine. So visibility is there. So 1 plus 2, 3. It's very simple. So here, what can I do is, next one, okay, next one, I can simply, I can write down. So this is a R program. This is a R program. This is a text. Just if I'm running it, I will get the output as the text. It's a simple calculator. You can use it. Plus addition, subtraction. Say for example here, it's a 5 divided by 10. Just then again I can. But what I'm trying to do is control plus enter will get the outputs. Okay. Just as a calculator, I can use the R programming. In the console, what can I do? I can prepare. So once if it is prepared in this window, if you are seeing it in this window, top right corner, there is a clear console or control plus L. If I'm clicking it, everything will be clear. I can start with the new. Okay. So for example, I can say 45 minus, then again 35. Control plus enter will run it, that it will throw the output. In order to make you to understand what is a console, how I'm feeding the data, and how I'm getting the output. Moreover, if you are seeing in the history, please see in the history, whatever I have done it, that it has been recorded here. In the history, what you have run it, what you have got an output, all these things you can see. Suppose if you would like to clear the history, see here in the history window, there is a brush icon, clear all history entries. I can click it, warning message shows, would you like to clear the history? Yes, I'm saying the history will disappear. Okay, the environment is a one when I'm declaring the variable that it will appear here. I hope now what do you mean by console and how I can use a console as an operator. Okay, so here I can resize the window. See here, if I'm putting a cursor in between the script and then again console, when I'm putting the cursor here, that it will become double-headed arrow, white color double-headed arrow. Just I can resize the window. Similarly, from left to right, see here, this is a script and this is an environment. In between, please see here, there is a one boundary. When I'm putting a cursor there, that is a double-headed arrow. Just I can increase the size of the window. Can you see here? So for 4 windows with which then again I have to get the outputs, then environment, then history, then again scripts, coding, what I'm trying to write, all these things, then again I can see. Okay, clarity is there now. What is a console? What I can write there and how I can get the outputs. I hope all of you are comfortable. Okay, right. Now I'm taking you to the next level. Now here I'm creating a variables. How can I create a variable? How can I store it? And how can I reuse it later? For example, here, this, whenever you would like to try to create a variable using script file, in that we can create it, we can preserve, and we can close and save, and we can recall. Not only that, in the script, once if it has been created, the variables will appear in the environment. Whenever it's required in the script at later point in time, I can recall. Let us take simple example. I am creating a variable called as a height. In this structure, see here, less than symbol, less than symbol, less than symbol with a hyphen, meaning here we are assigning the value to the variable. When you are seeing that greater than symbol is a prompt, height is the variable, the 2 is the value. the value 2 is assigned to the variable height. So for less than symbol hyphen, left hand side is a variable, right hand side is the value. Always, always in R, not only R, Python also. Right. So here I'm creating a variable called as a height, and as I'm assigning the value 2. When I'm recalling height, that it will throw the value. Similarly, here I'm creating a width variable and assigning a value, and when I'm recalling it, that it will throw the value of 4. That it will show the value of 4. Now, let us first try these two variables. Okay, and I'm minimizing it, and I'm taking to the script file. See here, this is a script file I'm starting with. In this, the greater than symbol is not appearing as well as the script file is concerned. But in console, the greater than symbol will be there. But in the script file, the line number will appear in the left hand side, 1, 2, 3, like. Here, what is a variable I'm creating it? Height. I am creating height. This is a variable name. What is the symbol I'm supposed to use? Less than symbol, hyphen. And right hand side, what I'm supposed to give? Value 2. Meaning here, I'm assigning the value to the variable height. And here, once if I have written in the toolbar, when you are seeing the script toolbar, there is an icon called as run. There is an icon called as run. Okay, this is a run button. The arrow mark is a run button. Either I can click the run button to execute this code, or I can put a cursor here. I can click Control plus Enter. Once if I have created a Control plus Enter, see here in the environment, there is a one variable has been created. See, can you see the here environment window? And here the height variable has been created, the value we assigned it. Now I am recalling height. So I am recalling the variable height, and if I'm running it, that it throw the value output. See here in the bottom. In the bottom, please see here in the bottom, that it throw the value for the variable that carries value 2. See here 2. Next one, weight. Similarly, we are assigning the variable weight less than symbol hyphen. The weight I'm saying height, let us the weight I'm saying it's a 4. Okay, and I'm running it, Control Enter, or this icon. See here, this icon. The icon in the script file, in the standard toolbar, the right arrow, green color right arrow is a run the current line or selection. Control plus Enter is there. I'm clicking it, that it has been done. See here in the environment, you can see here. The history is totally different. History, what you have done it, what you have got the output. That's all. Whatever you have written it in the script file will appear here. The environment that it shows what is a variable, what is its value. This is called as a global environment. Now I'm recalling the variable W. Here I'm putting a cursor here. W-E-I-G-H-T. Wait, I'm running it. So see here, I'm getting the output here. Right. Now, my dear friends, I would like to multiply the height and weight. Simply, I can execute the variable here. See here, in this script file, I can write height multiplied by weight. Okay, it's a multiplied by weight. I can. So the height multiplied by weight, I can say it's an output. So here, output, it's an output. I'm assigning the multiplication values to the output variable. So here I am saying height multiplied by weight. Okay, weight. Okay, that it shows here. Please see here, the tips shows here. Whenever I am writing, once again I will showcase to you height. See here, already the variable has been created. That is in the environment. Because it is in the environment, that is a pop-up is there. What can I do? I can simply click tab symbol to bring that particular variable into action. Then multiplication symbol, the next one is a weight. See here, if I'm writing down, the weight pink color is a variable name. So here, I'm running it please see here, I'm getting the output. Apo, the multiplication value has been assigned to what? Output. Already please see here, height is a value 2, output is a 8, weight is, that is the environment in which I can get. If I'm putting a value here, output, if I'm running it and the console, I can get the outputs. So especially the environment is a one that it will help us to store the variable whatever we created. With this, if I have closing the R programming, once again, if I'm reopening the R programming with the same variables what I kept it in the global environment, I can open the R program. Okay, right. So the script file, I can save it and I can recall once again. I can recall once again. See here, I'm clicking the save symbol or control that it shows saving. Let us take the R exercises folder. In that, I'm giving the name example. Okay, 10/8/2024 or sorry 12/8/2024. I'm giving the name. I'm saving it. See that it has been saved. Now please see this file name example 12/8/2024. So here now I'm closing the script file. Now I'm closing the script file. Okay, and I'm clearing the console and I'm clearing simply I'm closing the R program. I'm clicking save means that it will be saved. I'm not saving it, even though if I'm not saving it, whatever I left with which the environment will be opened. I'm saying don't save. Once again, I'm opening an R programming in order to showcase to you. See here, I'm opening an R programming. The script file will not be there. The console will be empty. Everything is there, but the environment, it's also empty because I have not saved it. History also is there. History will not be cleared. History will be there, but environment, it's an empty. Unless otherwise, if I'm not saving it, the environment will be reopened. The history is there. The history I can save. Suppose if you are not interested to keep the history, you can clear this also. I'm clearing this one. Now I'm opening up the script file. Please see here, it is not a new script file. I'm opening up the script file. Okay, from the file menu, it's an open file. I'm going to my location where I have preserved it. Okay, I'm opening up example 12/8/2024 file. I'm choosing it. I'm opening up. Automatically that will be loaded. Please see here, all the things has been loaded. I'm clearing the console window also. Please see here. Now, if I would like to rerun, I can select the entire thing. One single stroke, I can click run. Everything will be run, or one by one, line by line, I can run. That is the beauty I have shown to you in the PPT. What is an advantage? Line by line, we can run the program. Or either I can select all and I can run in single stroke. I'm taking all and I'm running it here. Please see here, everything has been run. The output has been shown in the console window. We have created a variable height. We assigned the value 2. We retrieved the value 2. We assigned the value 4 to the weight variable. We retrieved the value of the weight. We multiplied the height and weight and assigned to the output. The output we have get it. Okay, are you clear now? Yes. So what I'm trying to convey here is the basics of Excel. How can I use the console as a what, my dear friends? Calculators, simple window to run basic calculations. How to create a script file, how to create a variable, how to assign the value, how can I get the outputs. Now, are you clear now? Yes or no? Just I'm giving a breathing time for you to ponder over and say if you are comfortable, yes, in the chat window. I will proceed further. The learnings are R Studio, the environments, followed by What do you mean by script window, console window, environment window, plot window, plot or file, whatever may be. Okay, right. Shall I go further, my dear friends? Shall I move further? Right. Okay. Thank you. Thank you so much. I'm taking you to the next level. When I'm coming to the this workspace, I already explained. And this workspace, one more thing, there is a function called as ls. The ls will list out all the variables that is in my workspace. Say, for example, here I'm opening up here and I'm writing ls. ls means a list, open bracket, close bracket, and I'm running it. Please see here, whatever the character. So the environment is empty. I cleared everything. So here the character is 0. Okay. So what I'm trying to do is I'm running all the steps 1 to 6. I'm running now. Now I'm running the list function. Please see here, the list of functions shows what are all the variables are in my working environment. Please see here, height, output, weight. 3 variables are in my workspace. In case if these variables are not in my workspace, I can't recall and I can't use it for the calculation purpose. Please understand. So whenever you would like to do some calculations, whether this particular, normally they are called as an object. I'm using the word variable here. In R programming, everything they are called as an object. Whatever the objects you are using, that's supposed to be in your environment, then only you can recall the objects in the script or in the for running, and that will be run and the output will be thrown in the console window. Okay, are you clear now? Say, for example, here, see, once again, I am clearing the variables here. See, I'm clearing the variables, and the console also I'm clearing it. Okay, the history also I'm clearing it. Okay, clear now? So everything I cleared it. Now I'm executing the last line alone. ls open bracket close bracket. I'm running. See here, what is the thing has been shown in the console? Character 0. Nothing is not in my workspace. After running this lines, if I am asking the R programming how many variables are or how many objects are in my workspace, that it will show. See here, that is a workspace in which I can show the run, height, output, weight. There are 3. Okay, so you have to be very cautious whenever you are working with whatever the variable, what are all the variables are available in your workspace, and a library also. Not only that, not only variable. That is why I'm saying that whatever may be in the R programming, that is called as object. That may be a variable or that may be a package or whatever may be, that is called as an object. That object supposed to be in our environment. Once if that it's lying in my environment, then only I can use it in the script file to run. Or otherwise, the script file, even though I preserved, I saved, and I have reopened it, I can't run that particular line one after another, without recalling the packages, without recalling the variables. I can't run it. Okay, right. In other occasions, I will showcase to you. Suppose in case if the objects are not lying in my environment, what will happen? I will showcase to you. Okay, are you clear now? Are you clear? Shall I proceed further and come back to the chat window? And are you clear now? Anybody else can come forward? Workspace, console, script file, and output file like a plot. Is it very clear? Now, without understanding this one, you can't. Hereafter, whatever I'm trying to narrate is a very easy. Straight away, I will take you to the loading of Excel files or text files into the R, and how can I run cross tabulation and all the things. It's a very easy for you to understand. Okay, right. Thank you, Nikita, and I'm taking you to the next one. Okay, right. So, can I read the files from the Excel? Yes, I can read the files from the Excel, and then again I can load it. In the environment, please see here, this is an environment file, and I'm in this one, if you are seeing it, from text base, from text reader, from Excel, from SPSS, from SAS, from statistical packages, okay, stat. So from any one of the sources, I can import the data. If I'm clicking from Excel, the import window will appear. In that, the file URL, browse windows there, I'm clicking it, and any one of the data, I can take it here. See here, I'm taking some of the simplest data, I'm taking it, product sales, I'm taking it. I will open up the Excel file later point of time, and I will showcase to you also. See, if I'm opening up here, that it will be retrieved automatically, and that it will shows here. See here, date, sales rep, markets, product, cost, units, sales, like. And when you are seeing, these are all the variables, and there is a type of data also has been shown here. See here, double, character, character, double, like that it has been shown. System recognizes the data type. You can change the types also. Suppose, say for example here, it is not a double, it is a integer, it is a numeric. I can change the variables also. See here, numeric, I can keep it numeric. Like I can decide the data type also here, and I can load it. Okay, are you clear? And this is not the double, actually date, and this is a date. I'm clicking the date. See here, automatically that it will be recognized, and that will shown like this. See here, now the date has been recognized as a date. Sales representatives, already the system recognized as a character, I'm leaving it. Market, character, product, character, cost, I have converted into numeric. Like the unit is a numeric, and this is a whole number. Okay, I can click it. This is a numeric. I'm loading it as a numeric, and here I'm sales value, I'm clicking it as a numeric. Double is a one more precise value. It is also a numeric only, but it's a more precise value. Okay, right. See here, I'm viewing it here, and when I'm seeing it in the bottom, I can see here, and this is a one. I'm minimizing it. I'm showcasing to you. See here, this is a one. Okay, see here, this is an import window, and this is a code preview. So this is a code, and what is the code you are supposed to write down? For reading that library, sorry, for reading the Excel, we should install the, we should bring the library called as a read Excel. And before that, I would like to introduce what do you mean by installation of packages, and as well as bringing the packages into library. How? I will showcase to you. Once, for example, here I'm trying to import. Already I have installed this package, and that is not in library, but when I'm bringing it into import, automatically that it will be brought it into my thing. Okay, see here. So everything has been downloaded here. Please see here. This is a window. Product sales is appearing as a as a window. Then again, I'm seeing it. See here. So one. So what is an object? This is an object. This is called as a data frame. This is called as a data frame. What is an object? See here in the global environment, I'm seeing 43 observations, 7 variables. 7 variables means date is a one variable, sales rep, market third, product 4, cost 5, unit 6, sales value 7. 7 variables are there. How many observations or how many records? The records are all 43 records are there. That it has been loaded, and the things has been shown here. See here, the things has been shown here. Data types, everything has been shown here. Date, text, numeric, numeric. Like this is a one. Okay, are you clear? Right. See here, I have loaded, and that it's available in the environment. Now I'm closing this product sales window. That is a data frame. Now I'm opening up a new script file. Here, what can I do? I can apply some of the inbuilt functions in the R programming. Now I would like to review that particular product sales. See here, the function called as a view. If I'm trying to type view, that it's pop-ups. Once it's pop-ups, I'm clicking tab symbol, open bracket, close bracket is appearing here. Now here I can write down the product. This is a product. See here, product. If I'm typing product, product sales with the icon, table icon. Okay, this is a data frame. If I'm clicking it here, that it will taken up into the brackets. That it has to be run now. If I'm running now, please see here, I can see the output. See here, this is an output. This is an output. Okay, are you clear now? So I can view it. What is a product sales? I can view it in the script file itself. In the script file, one among the table that will be shown here, and I can see the table. Now I can start to reuse that particular tables. I can reuse that particular table. Okay. How I'm bringing it to Excel? All of you are comfortable? Yes or no? I'm coming back here. Is it very clear? The learning here is how to download the Excel file. Similarly, Excel file, same as such. Okay, same as such. So any data source from which you can take the data. Now you can ask a question, sir, shall I input the data in the R programming itself? Yes, you can create a data frame. Say, for example, like how you are creating a table in Word document. 4 columns, 5 rows. After creating it, you are starting to input the data. Similarly, we can also create a data frame and we can start to give an input into the R programming itself. But we have to key in everything. Other way around, we can get the data from Excel or a text file or SPSS file or from SAS file, from any source. We can import the data also. Now you may ask a question, sir, I typed the data into the R programming. Can I export it? Yes, you can export either to the text file or an Excel file or an SPSS file, any file you can export. That is also possible. Importing of the data is also possible. Exporting the data is also possible. Okay, clear now? Clarity is there? Clarity is there? Right, okay. Thank you, Moguna Sundaram sir, for the message. Now I'm taking you to the next level. That is called as library. Okay, that is called as a library. Before starting the library, I would like to say some of the practices that it has been followed in the R programming. Okay, right. In the R programming, when you are seeing it here, there is called as a comment. There is a called as a comment. Okay, workspace comments. See, whenever I am simply creating a variable and assigning the value does not make any sense. After a certain point of time, when I am reopening the script file, nothing I couldn't understand. Now, what can I do? I can create a titles. So, for example, here, any comments under which you would like to create a quotes, what you can do is you can start with the hash symbol. After the hash symbol, whatever you are writing, system will assume it as a comments, that it will not be run. Okay, or otherwise, if you are not using the hash symbol, system will throw the error message, or when you are running the program, that will throw the error message. Okay, right. Now the first one, I'm creating the variable, create variable height and width. This is a very much clarity of the statement. Below that, I'm creating a variables. Now I'm calculating the area. So calculating the area, height and width is there, length and breadth or height and width is there. I can create a area. Now this is a calculations. So the calculation height into width, I'm assigning to area. Then print. This is called as an output. I can get the outputs. Okay, are you clear now? And after the hash symbol, if we are writing less, this will not be executed. Example I have given, x less than -3. If this is a code, that it will not be executed. Why? Because the starting one is the hash symbol. Nothing will not be executed. Okay, right. I'm sharing this PPT to you, and later point of time you can reopen and you can recollect and you can re-equip yourselves. Right. Right. Now I'm taking to the next one. It's called as a set directory. In which directory I would like to preserve my files. For that, its a symbol here is a set WD. WD means it's a directory, word directory. It's a file path I'm supposed to give it here. To know the set directory, get directory also I'm supposed to give it. Okay, get directory, set directory. Now let us see here, set directory, get directory. So I'm opening up the file, 1 minute. Okay, in the intro, I'm sharing the R file also, so that what you can do is you can open up the script file. You can open up the script file, and what you can do is you can run it each and every one, and you can see the things. Now I'm clearing all the objects, history, everything. Okay, and I'm closing the previous script file also. Now I have opened up the already prepared script file. Okay, right. See here, in this I will tell you one by one. Now, anyone can say what do you mean by x here, and what is the right hand side one? What is the x here? What is the right hand side? Anyone, please come forward. Please open up your
The
microphone and
variable,
tell me.
the variable and the value.
Yeah, variable is an x. What is the value here? C123. And what do you mean by C and what is this? Then again, let us see the data structure. At the time we can learn. The second one is a y variable. And in this is a sequence. I'm asking the R programming to create a sequence from 1 to 100 with a step 2. Meaning 1, 3, 5, 7. Like 1 to 100, the variables will be created. Now I'm running this one. See here, I'm running this one. I have run it, the object has been created. Next, I'm running, the object has been created. Now I'm recalling the variable x. What is the x? 1, 2, 3. See here, the value 1, 2, 3. Now I'm recalling the y value. What is the y value? I have created a sequence starting from 1 to 100 with the step 2. Okay, right. Now I'm running it. Please see here, the output, I'm getting it in the console. See here, 1, 3, 5, 7, like up to 99 I got it. See here, all the then again odd numbers, right? Now this is an example to learn all these things. Then again I'm showcasing to you. Now how many variables
Sir,
we created? Yeah, please tell me.
sir, I have a question.
Yeah, please,
Sir,
ma'am.
yes, sir. Like in console, why it is showing only 1 to 99? Why not 100?
No, what I'm trying to say is with the steps of 2. 1 after
Okay,
which
okay.
what is a 3? 3, next one is a 5. So 100
Okay,
cannot
okay.
be included.
Yes, got it.
Once again, I am making it as a 101.
Hmm.
Okay, or
It will
102,
continue.
I make it as a 102. Now
Hmm.
101 will be left and 101 will be included. Once again, I'm running it and
Yes,
I'm
sir. Yes.
running the Y. Please see here, 101 will be included. Can you now understand?
Yes, yes, sir. Yes, sir. Got
Right,
it, sir.
okay,
Thank you.
right. Now, how many variables you created?
Excuse me, sir. I just wanted
Yeah.
to clear one thing. Why have you written C? I was not able to understand earlier.
Yeah, I will take you. Time being, keep it aside. Data structure we are supposed to see. At the time, then again, I will tell you what is the C and all other things. Time being, then again, please accept it as such, and I will come back to you and I will talk about in this data structure shortly.
Understood.
Okay? Right, okay. How many variables are there in this? How many variables we created so far? In the environment, how many variables are there? Please see here.
2.
2 variables are there. So
Two,
the ls function, the list functions will list my variables. See here, I'm listing here in the console. Can you see the thing xy? Right? And afterwards, simple functions I can use. These are all the inbuilt functions. Sum function, sum x. What the system will do? The system will sum up all the elements 1 plus 2 plus 3. What is an output? Probably for sum of x. What is an output? Yeah, anybody? I'm asking the system to sum up the x variable. What is the value be assigned to the x variable? 1, comma 2, comma 3. If I am summing up all the three elements, what will happen? What is an output?
6.
Yeah, very good. See here, I'm getting the 6. Can you see it in the console? And similarly, sum of y, I'm getting it as a 2601. The similarly mean value, I can calculate. Similarly, mean value of y, and variance also I can run. What is the variance? What is the variance of y? What is the standard deviation? The standard deviations also I can calculate. Okay, I can calculate the standard deviation also. Time being, please set aside what is the inputs I have given na.rm. Forget about it. Don't bother about it. So here the learning here is, after creating a variable, I can execute the all statistical function. Sum, mean, max, min, standard deviation, variance, all functions I can carry out. Similarly, now we are into set directory. Set wd is a setting the directory function. In that I am giving the path with the double quotes, d colon forward slash r exercise files colon. See here in my window. So r exercise, where is my r exercise? Is there? Local drive D R exercise. See here, local drive D R exercise. So what can I do is, so I can click it here. See here, if I'm double clicking it, see I'm getting the path here. See here, I'm getting the path in the window explorer. After opening the folder, if you are clicking it, you can get the path, and then again we can use this one, and then again we can run. The one difference there is a backward slash, here is a forward slash. I'm running it here. The directory has been set as a dir files. If I'm saying get directory, in which directory I'm working, if I'm clicking it, see the system will throw d colon forward slash r exercise files double quotes. So this is a example of how can I set the directory in the R programming, and how can I know which directory in which I'm working. Okay, are you clear now? Yes? Yes, are you clear?
Yes, sir.
Right. Uh, shall we make a break of 5 minutes? Is it required, or shall I continue? Shall I make a break? Right now in my watch, 7:59 about to happen. So 8:04 sharply, by 8 o'clock 4 minutes. Let us all reassemble here and we can start with. I'm online only. Those who would like to clarify the doubts, they can clarify the doubts. I'm not going for a break. Those who would like to go for a break, let them go for a break. And I'm encouraging the participants to ask any questions. Time being, then again, let us, I'm trying my level the best to answer your queries. And then again, we can resume the classes by 8 o'clock 4 minutes sharply. Yeah. Uh, Dear colleagues, let us start with the session. Now I'm taking you to the next level. So far, what we have seen is R programming, R window, R studio. Then in R studio, script window, console window, environment, then plot window. Then subsequently, we have seen how we can define a variable, assign the values, recalling it, doing some basic operations. All these things we have covered. Similarly, we have learned the set directory also, how to set a directory. That also we have covered. Now let us cover the package installation. There are n number of packages are available, freely available, that we can download and we can keep it in our system. And whenever it is required, we have to bring it to our workspace. For installing the thing, see here, what we are trying to do is, okay, what trying to do is, see here, this install dot packages, open bracket, close bracket. We are using this particular function in R. This is for installation purpose. Once it has been installed, again, whether that it's available for the usage, no. That we have to bring it into our workspace. For that, we are supposed to use a function called as library. Library. Okay, are you clear now? Right. Now, with this knowledge, okay, with this knowledge, we can go to the example here. I'm taking you to the R Studio. Okay, I'm opening up a, then again, installation process. Okay, installing the variables. I'm closing it. Okay, don't save. And I'm clearing the windows also. Everything I'm clearing it. That is very, very important. Clearing the history and then again environment, or otherwise the environment, the variables will lies, and that it will create a complications. Always we may receive the error messages. Okay, right. Now this is a library installation process. Then again I will showcase to you. And 1 minute. I'm opening up already one opened file. Then again, I will take it. This is a cross tab. See here, cross tab. Not cross tab, cross tabulation. Let us take the cross tabulation. Okay, right. Here I'm using some of the Excel files. Can you now see the thing here? What is the for installation? What I'm supposed to do it? Installation. See here, installation packages. Installation packages. What is the installed packages? Installed packages is the one that it will tell me what are all the packages that it has been involved in my system. I can see also. For installing the packages, I have to write them. See here, there is a package called as a discrete, DESCR. This is a package name. Initially, what I have to do it, I have to type it like this: install packages DESCR. I have to run it. Once it has been run, that is available in my system. See here in the plot, packages are there. I'm increasing the size. Can you see DESCR? That is the installed packages is available. See here. Once it has been installed, that it will be available here. Read Excel. Already I have installed the Read Excel file. Read Excel package. This will help me to read the Excel files. Okay. Similarly, the DESCR, that is a discrete. One is the package that it will be loaded into the, or that it has to be installed in my system. See here, the beginning, very beginning itself, I have lost the thing. See here, DESCR. Can you see here? So once it has been installed, I have to bring it to my environment. See here, I'm taking here 1 minute. See here, in the environment, nothing is there. See, after bringing library, I am typing library, the function has been opened. Now what I am supposed to bring it here? DSCR. See here, the package is there. See P. pink, that is a violet color with the P symbol, DSCR. This is a descriptive statistics. And that is a narration about that particular package, that it has been developed by the community. Okay, our community. I'm clicking it here, that it has been run. Now I have to run it. See here, carefully watch. In environment, nothing is there. After running this one, please see here. After running, I'm running it here. See here, the library has been loaded. And after the library, I have to bring it to my workspace. For that, I have to type require DSCR. If I'm bringing it, automatically that it will be brought into my package. See here, now that is available. When you are seeing it here, the check mark will be there. If you are seeing it, if it has been loaded, you can see the check mark here. Even if you are clicking a check mark, automatically that will be loaded. Another way around, clicking this, selecting this descriptive statistics, checking, automatically that will be loaded. Okay, right. In the history, if you are seeing it, what I have done it, that it's available. So I brought the library here and I made it as require. Require means that will be loaded here. Okay, right. Now I would like to import the data. This descriptive statistics is a one that will help me to make a cross tabulation. Okay, right. Similarly, my next step is bringing the read library. So now I'm bringing it, I'm running it, and I'm bringing the read Excel. After running the read Excel, then again I have to set the directory to pick up the file. So now I'm setting the directory. Sorry, this is a wrong. I put a. I'm running it here, and I set the directory. Now the product sales. I'm creating a variable called as a product sales. This is a function read underscore XLSX. Then the path of that particular file. If I'm running it, I'm getting the product sales. The product sales is here. See here in the environment, can you see product 43 observations, 7 variables. Even what can I do is here I can view it. So already I have shown to you view function. In the view functions, I'm saying product. See if I'm typing it, that the data frame will be shown like this. I'm double clicking it, automatically that will be inserted. I'm clicking Control Enter, that it has been run. Now this script file next to the tab, the table has been opened. This is a table, data frame table has been opened. Now this one I'm attaching it. Attaching it means till that particular removal, the product sales, the system will assume that the whatever the column name I am saying is from the product sales, or otherwise each and every time I have to say that product sales, in which once again I would like to say in the product sales, say for example you are talking about the markets. Markets is the column name. So what we have to do, say product sales in which the market column we have to say every time. Instead of that, if I'm attaching the product sales, hereafter there is no need to say again and again product sales. Only I can say that the column name alone, system will take the column name from the table or table what I have attached here. Now I'm creating a cross tab with a counting. Cross tab is a function that it's available from the descriptive statistics. Once if this package has been installed, then only you can use this particular function, cross tab. In the cross tab, I'm saying markets, products. What is the thing here? The markets. What are all the markets are there? East, west, south. What are all the products are there? Pencil, binder, and all other things are there. Now I'm using these two columns or variables to construct a cross tabulation. So when I'm running the cross tabulation, please see here, I'm getting the output. See once again, cross tabulation, creating, I am attaching it. First I am attaching it, and afterwards I have to run it. See here, figure plot new. What is the mistake I done it? Once again, I will run it one by one. See view is properly working. I have to attach the product sales. Yes, that it has been attached. Then now I can say cross tabs. I can run it. Here is in plot new, figure margin too large. Okay, 1 minute. Because of that particular the visibility, I'm facing the problem. I'm reducing it. Okay, I'm running it here now. See here, I'm getting the output. Can you see the output? Because in an enlarged window, that is not compatible to accommodate. See, can you see the console window? Once again, I'm cancelling it. I'm running that the cross tab alone. See here, in the top itself, you can see. Can you see the window? Market central, east, west. This is a total. Products are binder, desk, pen, pen set, pencil. So total. What is the process has been done? Counting process. In central, how many binders? In central, how many desk and all the things. In this one, this is a graphical presentations. I can simply click the zoom. The zoom will take me to the separate viewing window about the graphical presentations. I can get it. This is an example of a tabulation. This is a counting process. So if I'm using the T apply function, in the T apply functions, I'm using units. The list is market products. The calculation is sum. What is the units? Once again, I'm taking you to view that particular product sales window. I'm running it. I'm showcasing here. What is the units here? The units is nothing but number of quantities sold. Say, for example, John's 95 units, he has sold it. So the units is nothing but the number of quantity has been sold here. See, in T apply, once again, I'm increasing the size to make you to visualize clearly the objects or the functions. See here, T apply. The same R file, I will share it to you. You can load it in your R and you can run it and you can experience it. Today itself, then again, I will share it to you. Okay. So T apply, units is the then again numeric variable, and list is what the rows and columns. In the rows markets, in the column products, and what is an operation? Sum. See here, I'm running it here. I'm getting invalid graphic status. Why I'm getting it? Because of the size. Now I'm reducing the size now. Okay. Now I'm running it here. Please see here. I can get the outputs. Okay. I can get the outputs. See here, can you see the outputs? Once again, I'm clearing it and afterwards I'm running it. Can you see outputs? Can you see the outputs? So central, east, west, binder, desk, pen, pen set, pencil, the sum of quantity that it has been thrown here. And when I'm running mean value, suppose if I would like to calculate the mean of the number of products sold, so I can run it and I can get the mean value. Suppose I would like to round the figures, the decimals are there. I would like to round the figures. Simply, I can use a function round. It's like Excel functions, how we are executing the Excel functions, sum, open bracket, range. Like a similar way, we can call the functions, we can give the arguments, and we can run it, and we can get the output. But for that, what is required is understanding the data structure is very, very important. This one, I would like to take it to the next level. Now I'm showcasing round function, similar to the Excel function, round function applying. Within the round functions, I'm applying the entire table preparations, and the round functions in which I'm saying that the number of digits is 0 and I'm running it. Please see here, I can say, see here, I can run it here, I can get the output. Why I'm getting the wrong answers before is because I selected the items and I run it, but that is a mistake. Without selecting, at the end I would like to cursor and I have to run it, or otherwise I have to select the entire line and I have to run it. See here, without the, again I'm trying to increase, let us see, I'm increasing the size. Can you see the table here? Can you see the table? Central, binder, then again without the decimal points I get it. Previously with the decimal points I get it. Okay, are you clear? So what can I do is, in this exercise, what I did it is, I have installed the package. What is the package I have installed? Discrete statistics, the package I installed. After the installations, simply can I use it? No, I have to bring it to the library. After the library, I have to bring it to the workspace. For that, require is necessary. Then followed by, I install the read Excel one. I brought it the read Excel. Already I installed it. Read Excel, I brought it into library. And a set directory, I set it. And I have imported the data. Even this ninth line is not required when you are manually importing it from the environment window. Right now, I'm viewing the product sales and overview. I'm attaching this product sales data table. Why? Because without saying again and again the table name, simply I can say the column name alone in the cross tab. Or otherwise, here, what I'm supposed to do is I have to write the table name, product sales, then followed by dollar symbol, markets, I'm supposed to say. The dollar symbol is a 1, left hand side is a table name, right hand side is a column name. So like each and every time I'm supposed to write down. In order to knock off such a laborious work, I'm attaching it. Then I have applied a T apply functions to bring the calculations, the sum calculation, mean calculations, and all the things. Round is another functions also I have demonstrated to you. I have done it. What you can do is you can open up this my script file. You can open your own empty script file. What you can do by seeing, you can type, and then again you can execute one by one. Mere practice that it will take you to the next level. Here only I am demonstrating and I am making you to understand. That's all. Okay, are you clear now? So with the demo, I am keep on making you to see what is happening in the R by live I am showcasing. Now I am pausing for a couple of minutes. For any queries, I will clarify. The next one, I am taking the data structure. Is it okay? Clear? Anybody else can through the chat communicate?
Clear, sir.
Right, okay. Now I'm taking you to the next level. It's a basic data type. Data type is a one, data structure is another one. Data type means here I can say logical value, numeric value, even numeric, integer, decimals. These are all the data types. Okay. And character. This is a one of the data type. Then I'm saying I'm leaving all these things and I'm straight away I'm going to the data structure now. So the data type, what I have shown to you in Excel, date is a variable data type, numeric, character, okay, double. These are all the data types. Okay. Even a number can be defined as decimals, whole number, complex number. Like I can define the data type. Okay, this is a one part. Already you are having a good exposure about it, the data types. There's no need to talk much about it. But the data frame is very, very important. There are 5 data structures. In addition to that, one more thing is called as a factor. Factor is not a data structure actually. How the R handle the data structure. We can get it inputs through the learning of factor. Right. What are the data structures are there? Vector, matrix, array, data frame, list. There are 5 data structure. In addition to that, you can add one more factors. That is also you can include it as a data structure. Nothing wrong about it. Okay. First, let us take the vector. By pictorially, I have represented. What the Excel data, what we imported is an example of a data frame. What the Excel file, market product says, that is an example of a data frame. Okay, right. So with this, I'm taking you to the vector. What do you mean by vector? Vector is nothing but it's a sequence of data elements. It's a basic type that may be a character or a numeric or a logical. This is an example. So the 11, 12, 11, 13, these are all the numbers. And the C is nothing but it's a concatenate. In Excel, we are using the function called as a concatenate. So the concatenate functions combine these values together. So the value what here is 11, 12, 11, 13. So this is a series of, see here, sequence of data elements. What do you mean by sequence of data? This is a sequence of data elements. Basic data type. This is a basic data type. All data types are all unique. It's not the combinations. And the C is the function, concatenate function. This is combines. And this is a sequence of elements. So it is called as a vector. I am assigning this value to mark. I hope what do you mean by the left hand side of the less than mark and right hand side. The left hand side is a variable name, right hand side is a value. Here, by using the function called as a concatenations, I am combining these values. 11, 12, 11, 13, any value. Sequence of data elements, same basic type. Suppose one is the numeric, one is the character. Again, it is not a vector. It is not a vector. Okay. And this is a vector. I can say here, see here, it is a single value vector. I'm saying my apple. Now anyone can tell me the first one. Let us take the first one. The green color, I have shown the 5, and the black color, I have shown my apple, and a less than hyphen symbol. What do you mean by here? This one. Yeah, anyone can come forward and tell me. Come on, anyone, please come on. Please come on. I'm encouraging you. Come on. Right or wrong, don't bother.
My apples is the variable and
Very good.
the
Very
value
good.
that we have assigned to the variable.
Superb. Here, how many elements are there? Only one element. That is why it is called as a single value, single vector, atomic vector. This is called as an atomic vector. An atomic and vector may be a value or series of value, or that may be a character also. See, next one example I have given, my oranges. My oranges is a variable name. What is the value I'm giving? This is called as a string. Double quotes, 6 double quotes. So this is a character. Now, when I'm saying this is a function, is vector my apple? System will say true. Is vector my orange? Yes, true. That it shows true. Okay, right. This is an example of a single vector. And what is the learning point here? Only elements of the same type. A series of elements, same types is called as a vector. An atomic vector is a single value, and that's all. Now, here I am taking here. This is a coercion of vectors. In this, can you now, anyone can come forward and say what is the right hand side and what is the left hand side of the less than hyphen marks? Yes, anyone? Anyone? Can you say anyone?
We have assigned different characters to the variable drawn ranks.
Yeah, drawn ranks. Very good. Different, that is a elements. 7 is a numeric, 4 is a numeric, A is a character. See, what we have learned about the vector? Vector is a sequence of elements, same basic type. If it is a numeric, supposed to be numeric. If it is a character, it is a character. If it is a logic, it is a logic. Otherwise, it is not a vector. Suppose if I am assigning, what the system will do is that it will force all the numerics into character. See here, when I am taking the output, after creating this variable or object, when I am recalling it, system will throw the results like this: 7, 4, 8, 10, K, 3, 2, like that it will showcase. Class is a function. I'm asking, what is the class of this variable drawn ranks? Drawn rank is my own given name. Any name you can give it for the variable. What is this class? The class, what the system says, is a character. So the coercion will take place when you are creating the elements with the multiple elements together, automatically that will be converted into character. That's all. You should be very careful while you are combining it, right? So this is all about the learnings of the vector. Vector is nothing but a sequence of data elements having the same basic types. Either that may be completely character or completely numeric or completely logic. This is an example. In this example, 11, 12, 11, 13 is a complete numeric, so that the what we have created, the data structure is a vector. Here, this is an example for this atomic vectors. And what I have introduced is a coercion for the vectors. Coercion for the vector means even though we are saying 7, that will be automatically converted into character by the R programming. Okay, that you are supposed to aware about it. Now I am taking you to the next one is called as a matrices. Matrices already you may aware about it. It's a one-dimension matrices or a two-dimension matrices. That's rows and columns. Okay, these are all the examples. Matrices. Matrix is a function. What you can do is I'm giving this one. You can take it. This matrix is a function. So if you are typing and if you are running it, you can get the output like this. 1:6 will generate the 6 elements, and the n row means number of rows 2. See here, the 2 rows has been created and the 3 columns has been created with the generated element of 1 to 6. I will showcase to you. I will run it and I will showcase to you here. I'm opening up the R Studio. Okay, and I'm opening up a new script file. Okay, what is the function? Matrix. See here, matrix. In the matrix, what I'm supposed to do? See here, I'm showcasing the PPT. See here, 1:6. See here, 1:6. That it will generate what? 1 to 6 elements. Now, n number of rows. N number of rows. See here, n rows. If I'm typing, system shows matrix n number of rows. How many rows are there? If I'm clicking tab to bring it the n rows argument, in that I'm saying 2 rows. Apo, how many rows I'm creating? 2 rows. And obviously 6 elements are there. 3 columns will be generated. See here, if I'm clicking it, automatically that it will throw. See here, again the problem. See here, can you see the matrix here? Can you see the matrix? Can you see the matrix? I'm highlighting here. Can you see the matrix? Okay. Right. Similarly, n number of matrices I have given to as an example here. Please leisurely do it and understand. So this is a matrix is another type of structure. The next one is a factors. Factor is a limited number of different values, belongs to a category. In general, I can say that it's a nominal data or an ordinal data. In research methodology, whenever we are trying to learn the primary scales of measurements, we are learning nominal, ordinal, interval, ratio data. In that, the first 2, nominal and the ordinal, belongs to that particular variable. That is a factor. Okay. Say, for example, if I'm having my own student's name list, even though it is a character, it is not a factor. Why it is not a factor? The name is not a factor because unique names. Suppose in my class, 100 students are there, 100 unique names will be there. But in a factor, it's a limited number of different values. Belongs to a category. For example, I can say gender. In gender, even though the gender, if I'm saying female, male, like if I'm typing it as an input variable, there is a character only, but again, it's a limited number of different values that it belongs to a category, so it is a factor. Like here, I am giving an example of a blood group. Blood group, the B, A, B, O, A, all are alphabets. Again, this is a limited numbers, so it is called as a factor. So the nominal data. So for example, I can say gender. I can say section A, B, C, D. I can say division ABC. I can say the levels of satisfaction, or I can say that say for example it's a good or bad, like a logical values or binary values. These are all called as a factors. Factors have a limited number of levels. Okay. Right. Okay. This is a one. Nominal and the ordinal. Ordinal is also there, but ordinal we are talking about the levels. Yes, the levels matters. The orders matters. We are mentioning it. For example, shorts size small, small, medium, large. In this, if I'm saying small, medium, large, this is a character. Again, it's a confined to a limited number of groups, so it is a factor. And again, the small, medium, large, it's an have its own order. I can order it, so the ordinal data and the nominal data both are comes under the particular factors. So the R handles the factors also, or handles the factors also. So to wrap up the factors for a categorical variables, it is a categorical variable. It's an integer vectors. Change factors levels are there. Orders whether it's a true or false. I can say if it is a true, it's an ordinal data. If it is a false, it is a nominal data. Now I'm coming to the list. The list is another type. In the vector, it's a one-dimensional. In the matrix, two-dimensional. In the list, different one. No coercion and all of these. Especially, I can take the example of a scenic song. When we are in the scenic song, we will say each and every song, we will say the title of the song. You say if we are title of the song, duration of the song, track. Duration is a date, time, and the title is a character, and the track is the numeric number. So three different type of data types. I'm keeping it together. That is why it is called as a list. A list is a one that it combines the entire thing. See, the list is a one. Please see in my presentation, different R objects that may have a vector, that may have a matrix, that may have a data frame, anything that it can be accommodated. No coercion. Say in the vector, if you are bringing together the character and then again number, the number will be converted into character. But on a just list, no coercion. Okay. So the best example here, the scenic song. What is the title? What is the duration? What is the track? Like a different informations with a different type of data. I'm keeping it together. In which structure can I keep it? In the list. A vector is a sequence of numbers, same basic types. Then matrices, two-dimensional data set with the same elements, not different elements. Then again, factors. Factor is nothing but it's a categorical variable with the limited levels. If it is not the limited levels, it is not the factor. The factors may be a nominal data or an ordinal data. And in the name list is a one that it's accommodate the different type of a data structure and the data type. Now, the last one, I'm taking the data frame. The data frame is a one. Very often we are using it. It is not a matrix. It is not a list. It is not a vector. Whatever the data frame. The example, the rules here is the rows are observations, columns are variables. It is not the matrix. Matrix will contain only the same elements. But here, if you are seeing, the same elements are not there. Rows and columns are there, but in the matrix, the body of the matrix is supposed to be the same element. But here it is not like. Okay, the columns, what you are naming it, the columns are variables. The rows are observations or records, whatever the name you can call it. So this is a best example. This data frame I can import from the CSV file, SQL file, Excel file, SPSS. So in Excel, SPSS, SQL, .csv files, what the data structure we are keeping it? Data frame. Okay, are you clear now? Right, today I'm stopping up to this. Now time is 8:38. Already I took it 8 minutes more. It is not justice. And again, in order to complete that one topic, then again I completed. Tomorrow, let us see the various data types. Once again, creating a variables, creating a data structure, recalling the data structure in the R Studio. Let us see. And after seeing that one, we can move to the graphical process. We can do some basic statistical analysis, descriptive statistical analysis, let us do, and afterwards we can move to the graphs. And for which I am planning to run a regression analysis. Any regression analysis or bar chart, whatever you would like to ask me to demonstrate, I will demonstrate few graphs. With this, I'm stopping and I am opening the floor to raise the questions. Any doubts or clarifications are there, please ask me. 1 or 2, I will entertain. Professor, another 1 or 2 minutes, we can wind up the session.
Yes, yes.
Sorry for the delay.
No,
I took
perfectly fine,
10
sir.
minutes. I took
Yes,
10
yes. Perfectly fine, sir.
Right. Any clarity is there? It's okay, fine. Wherever you are stucking to learn the R programming, I have thrown the lights. Even it is necessary tomorrow, then again I will recap the particular data structure once again, because last minute I rushed up. Tomorrow once again we can cover once again, and we can move to the creation of the data structure in the R programming.